Statistical methods. Comparing means. The goal of today's session is to understand and be able to explain when to use t-test in ANOVA, when to use an independent sample t-test and dependent sample t-test, the rationale for the t-test in ANOVA, the meaning of a t-value, f-value, and p-value, what explained and unexplained variability mean, and how to interpret the reporting of t-tests in ANOVA. Comparing means. There are two ways to compare the means. One is t-test, and the other is ANOVA. T-test is for comparing for two groups, and ANOVA is for comparing more than two groups. What is t-test? T-test is a test of comparing two sample means. There are two types of t-tests, independent sample t-test and dependent sample t-test. Independent sample t-test is used when two groups of participants are assigned to different experimental conditions or when they belong to two different groups, such as sex. Dependent sample t-test is used when a single group of participants take part in two different experimental conditions or go through two testing conditions, such as pre-test, post-test design. Now, let's talk about the rationale for t-test. Maybe you have heard that every test analysis requires a null hypothesis. The null hypothesis assumes that there is no difference between two sample means drawn from two groups or two conditions. In other words, there is no effect of independent variable on dependent variable. Most of the time, you want to reject the null hypothesis because you want to show with your data that the two sample means are different and there is an effect of your independent variable on dependent variable. So, how do we know whether to accept or reject the null hypothesis based on running a t-test? Well, what t-test does is to calculate a t-value, which tells you whether your hypothetical model is good or not by fitting it to your data. If your hypothetical model is good, you will reject the null hypothesis and conclude that there is a significant effect of your independent variable on your dependent variable. To calculate the t-value, there are two pieces of information you need from your data. One is explained variability and the other is unexplained variability. Explained variability is how much your independent variable explains your dependent variable. This indicates how good the model is, or the effect. Unexplained variability is how much you cannot explain your dependent variable by your independent variable alone. This indicates how bad the model is, in other words, the error. To evaluate your hypothetical model, a t-test compares how good the model is against how bad the model is. But what exactly is explained and unexplained variability? Let me take an example and clarify this. Imagine that I give this whole cake to each of you. My dependent variable is the amount of cake you will eat when I give this to you, and my independent variable is whether you are a sugar freak or not. I hypothesize that those of you who are a sugar freak will eat significantly more amount of cake than those of you who are not a sugar freak. But whether you are a sugar freak or not may not be the only factor which will explain your cake eating behavior. For example, maybe there is a sugar freak who will still not eat cake because she's on a diet and she knows how evil cakes are when it comes to losing weight. Or maybe there is a non-sugar freak who would still eat the whole cake because she's so frustrated about learning statistics and she will put anything in her mouth right now to make herself feel less miserable. The thing is, you guys are so unpredictable that it is impossible for me to build a hypothetical model which will explain 100% of your behavior for every one of you. So, some part of your cake eating behavior will be explained by my hypothetical model, but other parts won't be. That's the explained and unexplained variability in dependent variable. When you run a t-test, your goal is to get an effect as large as possible and an error as small as possible. This will give you a t-value as large as possible, which will ensure you that your model is good to go. But how large does the t-value have to be to tell you that your model is good enough? That's when the magic p-value comes in, which I'm sure you all must have heard of. Basically, p-value can tell you whether your t-value is big enough to say that your model is good enough. So you can say that p-value is like an insurance for the t-value to tell you if your t-value is doing a good job. Statistically speaking, a p-value or significance value is a probability of getting a t-value as high as the obtained t-value by chance. What does that mean anyway? That means if this probability is less than 5%, you try to run a t-test 100 times, and there is only less than 5 times t-value makes mistakes, and don't get the value as high as it's supposed to be. So you can think of a p-value as the number of times a t-value makes a mistake. So the larger the t-value, the smaller the p-value. Because if the t-value is large, that means the t-value is doing a good job. So the p-value only needs to catch a t-value a few times for making a mistake. I hope this metaphor about the relationship between a t-value and p-value somehow makes sense to you. Well, the bottom line is that you want a p-value to be less than 0.05 because this will allow you to reject the null hypothesis and conclude that your independent variable has a significant effect on your dependent variable. By the way, have you ever wondered why is p-value 0.05 and not 0.03 or 0.07? Well, the answer is as simple and as stupid as this. Because once upon a time, there was a guy called Ronald Fisher who said it should be 0.05, but not more or less. Many statisticians said that technically every model is different and every model needs its own unique p-value to be calculated, which totally makes sense. So far, not many educational researchers do something about it, because let's just say it's easier for us to listen to a stranger called Fisher and deal with just one number, 0.05, than listening to a guy called a statistician and calculating a new number every time they run a model. Okay, enough of talking about t-value and p-value. Now let's learn about two types of t-tests: independent sample t-test and dependent sample t-test. First, let's learn about independent sample t-test. Let's take an example of e-learning program. This is a quasi-experimental study where two groups of participants are placed, either in an e-learning condition or a control condition. The outcome variable is participants' computer skills. We want to use the independent t-test to test whether the experimental group and the control group differ in their computer skills in their pre-test and post-test. We would expect that the experimental group who had intervention of e-learning program would have higher computer skills in the post-test compared to the control group because of the intervention. This is how the t-value is calculated. Explained variability is calculated by differences in computer test scores between two sample means, namely the mean from the e-learning group and the mean from the control group. Unexplained variability is calculated by standard error of differences between those two sample means. This is how you report the results of t-test in APA standard. On average, participants in the intervention group had significantly higher post-test scores than the control group. Make sure to include the means and standard deviations for both groups. It is also important to include the t-value, degrees of freedom, and the p-value. If the p-value is less than 0.05, it means that the differences between the two sample means are statistically significant. In other words, there is a significant effect of intervention on people's computer skills. You can also additionally calculate the effect size, such as Cohen's d, to show how large the effect size of your intervention is. Generally, 0.2 indicates a small effect, 0.5 indicates a medium effect, and 0.8 indicates a large effect. Next, let's learn about dependent sample t-test. We will take the same example of e-learning, but this time we will not compare two scores between different groups. We will compare pre-test and post-test scores within the same group. We want to use the dependent t-test to test whether the experimental group improved their computer skills between their pre-test and the post-test. We would expect that the experimental group would have higher computer test scores in the post-test compared to the test scores in the pre-test because of the e-learning intervention. This is how you calculate the t-value in a dependent t-test. Explained variability is calculated by averaged differences between means of pre-test scores and means of post-test scores. Unexplained variability is calculated by standard error of differences between those two condition means. This is how you report the results of dependent sample t-test. On average, people improved their computer test scores after they participated in intervention compared to before. The improvement in their scores was statistically significant. Again, make sure to include the means and standard deviations for both groups, as well as the t-value, degrees of freedom, and p-values. Now let's talk about ANOVA. What is ANOVA? Just like the t-test, ANOVA is a test of comparing means. The only difference between t-test and ANOVA is that in the t-test, you can only compare two sample means, but in ANOVA, you can compare more than two sample means. ANOVA is based on F-test statistics, or so-called F-ratio. F-test tells us whether there is an overall effect of groups or experimental conditions. One thing F-test does not tell us, however, is the details about how each condition may be different from one another. Let us first take a hypothetical example. Couples get to know each other in various ways. According to these statistics, 90% of couples met online, 17% of couples met through a friend, and 15% of couples met in a bar. Let's say we want to find out which couple is feeling the happiest after some years later. The rationale for the F-test or ANOVA is the same as the rationale for the t-test. To test whether our hypothetical model is a good explanation of the data we have observed, we need to compare the explained variability against the unexplained variability by the model. Let me shortly explain how explained and unexplained variability for F-tests are calculated. First, there are three groups: the couples who met in a bar, the couples who met through friends, and the couples who met online. The vertical numbers show how happy couples feel after a few years of being in a relationship. The grand mean is the average happiness scores of all couples regardless of how they met. The group mean is the average happiness scores of couples in each group. There are 3 group means. The mean for the couples who met at the bar, the mean for the couples who met through friends, and the mean for the couples who met online. To calculate the explained variability, we estimate the differences between each group mean and the grand mean. We square those differences and add them up. This is basically the effect of the group on couples' happiness scores. To calculate the unexplained variability, we now estimate the differences between each group mean and each score from every couple within the group. We square those differences and add them up. This is basically the error in the model that is unexplained by the group factor. By the way, why do we always square the differences? This is because when we deduct one mean from the other to calculate the differences between 2 means, some differences are positive and some differences are negative. Squaring the differences make everything positive, which helps us interpret the numbers easier. So similar to t-test, f-test is calculated by explained variability divided by unexplained variability by the model. Explained variability is the average sum of squares of the model that was calculated based on differences between the grand mean and the group means, which I just explained. Unexplained variability is the average sum of squares of the residual, or the errors, which was calculated based on the differences between the group means and each score, which I just explained. And this is how you report the results of ANOVA. The effect of how couples met, bar, friends, and online, on their happiness was not statistically significant. Make sure to include degrees of freedom, an F-value, and P-value. Until next week, please do learning by explaining on this topic. By explaining to your friend what you have learned today, pay attention to those of the questions. What are the important and key concepts? What are the examples of those concepts? What are the connections between those concepts? What did you find interesting? Was there anything that was unclear or difficult to understand? And were there any questions you would like to ask me? Thank you very much and see you next week. Bye!